When solving linear equations, distribute to get rid of any parentheses, subtract all your x's to one side of the equal sign, and then solve for x. Let's do some examples. Example A, I'm going to distribute this 3 to get rid of those parentheses. I will also have to distribute the 2. 3 times 2 is 6x. 3 times negative 5 is negative 15. And I still have the plus 4 hanging out. 2 times 4x is 8x. And 2 times 3 is 6. You could go on and combine these two numbers here. They're both whole numbers without an x. Or I'm going to subtract the 6x to the other side. Move all of my x's to one side of the equal sign. 6x minus 6x is 0 x's. And over here on the right-hand side, 8x minus 6x is 2x. You don't have to do this step by step. I'm just trying to show you every single tiny step. You can do a couple of these all at once. Now we want to solve for x. I need to add or subtract before I can divide. So I'll subtract my 6 over to the other side. 6 minus 6 is 0. I'm going to add all those pieces together. Negative 15 plus 4 is negative 11 minus 6 is negative 17. And now divide by 2. Final answer, you can leave it in either fraction form or you can give me the decimal answer. I'm going to leave it as a fraction. Simplify your fraction if possible. In this case, it doesn't simplify, so that's it. Distribute. Here's where I see a lot of people try and make this negative 11 and distribute it, but this is 11 minus, not negative 11. Don't swap the order. You can imagine this as a 1. All we're doing is distributing the negative sign here. Negative 1 times x and negative 1 times 2. Now, move all your x's to one side of the equal sign. I'm going to add that x over 1x. And solve for x. I need to subtract before I divide. You can either leave your answer in fraction form or in decimal form. If you leave it as a fraction, make sure you simplify. I can take out 11. All right, let's do one last example. Distribute. I'm going to combine these two together first because I don't like having multiple x's on the same side of the equal sign. All right, move all of your x's to one side of the equal sign. Oh. What's going on here? This is one of the special cases. So, if the x's cancel out or we end up with 0x, like what just happened there, you have two options. You need to continue to solve the problem, and then if you end up with a true statement where the number equals itself, 5 equals 5, 2 equals 2, negative 5 equals negative 5, any number you plug into the original equation will work. So your answer is all real numbers or infinitely many solutions. If when you solve you end up with a false statement, two separate numbers, 1 equals 5, 6 equals 7, something that's not true. That means no number works, so your answer is no solution. So in that last example, our x's canceled out. And when I kept solving, I ended up with 42 equals negative 5. Well, that's not true. Those are two completely different numbers. So my answer here is no solution. There's not a single x that I can plug into this original equation to get the left side equal to the right side. Let's do another example though. We just saw an example with no solution. Let's do one where it's infinitely many. Solve for x. Distribute to get rid of any parentheses you have. Move all of your x's to one side of the equal sign. Oh, look, 5x minus 5x is 0x, so they cancel each other out. Continue to solve the problem, though. 10 minus 15. And now I ended up with a number equal to itself. This is a true statement, so my answer is infinitely many solutions or all real numbers. So that means if I substitute in a 1, the left side will equal the right side. If I substitute in a 20, the left side will equal the right side. Any number you can think of, if you sub it in for an x, the left side's always going to equal the right side.